Good morning. It is a pleasure to share to the academic community our research concerning teachers' professional development and professional practice. My paper presentation is titled Overcoming Teachers' Misconceptions Through Process Skills-Based Refutational Teaching. Before anything else, let's define first what misconceptions are. Misconceptions in science are alternative ideas about the natural world. They are conceptions that deviate from the current and accepted scientific understanding due to preconceived notions that are not challenged or a built-in system of thinking that tries to make sense of those notions to explain their confusion. Studies have shown that misconceptions in science prevail among students and in-service teachers as well. Misconceptions have the tendency to remain among children even after teaching. Consequently, they have been persisting in the elementary, secondary, and tertiary levels. Furthermore, teachers can also be the sources of misconception. One of the strategies used to challenge learners' misconceptions is the application of refutational teaching in the teaching learning process. Refutational teaching allows the learner to address misconceptions and experience cognitive conflict, which is the discrepancy encountered between what is observed and the cognitive construct of the learner. In the constructivist context, cognitive conflict can lead to conceptual change when the learner, in his initiative, modifies his existing schema to fit to the new information, a process called accommodation. Refutational lecture involves the following steps. Number one, presenting of facts. Number two, presenting the misconception. Number three, explaining the reason behind the misconception. And number four, inoculation, which is preventing the misconception from being assimilated when encountered again. Studies on refutational teaching through refutational lecture and text showed positive learning outcomes in correcting students' prior knowledge. However, there is also a downside to it. Previous findings show that some students still retain the misconceptions after they have been taught in a refutational manner. Researchers of this study propose a deviation from refutational teaching advocated by Kowalski and Taylor. Instead of reading a text or listening to a lecture, students discover, deconstruct, and reject their own misconceptions, and finally construct the accurate knowledge through minds-on and hands-on tasks in the teaching learning process. Previous studies show that retention of concepts learned is bolstered further when students discover, process, and apply information instead of passively absorbing them. Thus, researchers of this study seek to find answers to the following research questions. Number one, what are grade 6 science teachers' misconceptions about the human respiratory system? And number two, does a process skills-based refutational teaching improve teachers' content knowledge of the human respiratory system? So for the methodology, the study is a one-group pre-test, post-test design where 86 teacher participants were selected from two regional workshops conducted in northern and central Philippines. A 10-item quiz serves as the instrument to measure the change in their understanding about a certain topic, which is the respiratory system. Pre-test and post-test mean scores were compared using paired samples t-test to see if there was a significant improvement after the workshop. McNemar's test was conducted to determine if there was a significant number of teachers who corrected their current understanding for each item in the quiz. Intervention made use of process skills-based refutational teaching, which is a deviation from the refutational lecture by Taylor. This approach does not present the correct concept and the misconception right away. Instead, teacher participants were given a set of data or an activity. Then, they are tasked to answer the questions, eventually discovering their misconceptions and correcting themselves when they answer the questions. For the scope of the intervention, it covers the following: understanding the air we breathe, anatomy of the respiratory system, physiology of the respiratory system, application of concepts in life-saving techniques, and health issues concerning the respiratory system. Results of the study. The table shows teachers' prior understanding of the human respiratory system. All of the 10 items showed that a significantly large number of teachers have several misconceptions about the science ideas behind the human respiratory system. To answer the first research question, here are the misconceptions that were elicited based on the pretest using the 10-item quiz. Number 1, oxygen is the most abundant gas inhaled and carbon dioxide is the most abundant gas exhaled. Number 2, when oxygen is inhaled, it is used up completely. Number 3, nitrogen is neither inhaled nor exhaled. Number 4, when the diaphragm moves up, air is inhaled, and when the diaphragm moves down, air is exhaled. Number 5, space inside the chest cavity decreases when air is inhaled. And number 6, coughing is not considered a natural defense of the body. A significantly large number of teachers can be seen having misconceptions in the gases as shown in Statement 1 and Statement 9, indicating that teachers have realized that oxygen is not the most abundant gas inhaled and carbon dioxide is not the most abundant gas exhaled. In statement number 8, it showed a significant number of teachers correcting their answers, as shown by the table. The intervention made teachers realize that oxygen can be exhaled as well. The use of an empirical data with probing questions and the application of the empirical data like the table of exhaled and inhaled gases were able to challenge their misconceptions about the composition of inhaled and exhaled gases. The questions allowed teachers to use the data to make an explanation, an important feature in inquiry-based pedagogy recommended by the National Research Council. The discussion on artificial respiration made teachers realize that exhaled air still contains oxygen as shown by the table of exhaled and inhaled gases, and this amount of oxygen is sufficient enough to rescue the unconscious victim. In the refutational lecture, corrections can be made either by repetition or using an alternative narrative. In this case, the use of a practical situation serves as an alternative narrative to make the correction more effective. Unfortunately, it is only in item number 3 that the intervention failed to get a significant number of teachers who corrected their understanding when it comes to nitrogen as one of the inhaled and exhaled gases. There was a possible confusion in the way the statement was understood. During the workshop, the question was which of these gases is neither produced nor used by the body? And this question cannot be answered by the number 3 statement, which states that nitrogen is neither inhaled nor exhaled. Based on the table of exhaled and inhaled gases, what was inhaled does not necessarily mean that they were all used up by the body, and what was exhaled does not necessarily mean that they are all produced by the body as a waste product. Another oversight was the lack of follow-up questions on nitrogen. Furthermore, the discussion focused more on carbon dioxide and oxygen. For statements 2, 6, and 10, the intervention was able to garner a significant number of teachers correcting themselves regarding their understanding of the physiology of breathing. What is not shown here is that 55 teachers were incorrect for these three related statements when they took the pretest. Because these items cover related concepts, it implies that a majority of teachers have a misconception that the upward movement of the diaphragm takes place for air to be inhaled, and the downward movement of the diaphragm occurs for air to be exhaled. After process skills-based refutational teaching, 72 teachers were correct for all of the three statements in the post-test, implying that these related statements revealed consistency of their correct understanding about the mechanics of breathing. Teachers had a different understanding of diaphragm movement and its effect on the lungs. More than half of the teachers included in this study believe that the lungs expand when the diaphragm moves up, but later changed their answers in the post-test, indicating that the impact of the intervention was significant. The use of the manipulative model called lung chest model shows the movement of air relative to the movement of the diaphragm. Inferring the movement of the air was based on the inflating and deflating action of the plastic bags that represent the lungs. Observing and inferring skills help the participants construct the correct knowledge of the mechanics of breathing and reject the earlier misconceptions during the pretest. This was reflected in the result of McNemar's test for statements 2, 6, 7, and 10. Constructing the correct knowledge was made possible by answering the questions in the worksheet after manipulating the Langchess model. For statement 5, there were only 21 teachers who corrected themselves after the post-test, which is still a significant number based on the chi-square statistic obtained. However, the number of teachers who showed improvement in their understanding of Statement 5 was less compared to those who corrected themselves in Statements 2, 6, 7, and 10. This is an interesting finding because the movement of the diaphragm is directly related to the changing amount of space in the chest cavity. What the table cannot show here is that 49 teachers who answered Statement 5 correctly were incorrect on Statement 10, which states that the diaphragm has to move up in order to exhale. This would mean that most of the 64 teachers who were correct in Statement 5 during the pretest were unable to realize that the movement of diaphragm can alter the amount of space inside the chest cavity. Instead of constant repetition of correction, process skills-based refutational teaching reiterates the correct idea by applying what was learned into another situation and synthesizing the related ideas into a cohesive whole. This is another way of presenting an alternative narrative to eliminate the continuing influencing effect of misinformation. Prior to the seminar workshop, the pretest showed that 18 teachers did not understand that coughing is a natural defense of the body against any pathogen that could enter the lungs. After the workshop, results showed a significant change in their understanding about coughing. The number of teachers with correct responses increased from 68 to 82. Process skills-based refutational teaching made use of observing skills in understanding what happens inside the lungs of a chain smoker by simulating the smoking habit in a lung chest model. It confronted the earlier impression of coughing as having no use in removing harmful substances entering the respiratory tract. This was done by asking questions that made the participants realize that coughing expels the harmful deposits in the lungs when a chain smoker quits the habit. In summary, 9 out of the 10 statements showed a significant number of teachers correcting their previous answers. Process skills-based refutational teaching was effective in a significant number of teachers who participated in the regional workshops. Paired samples t-tests showed a highly significant difference in the improvement of teachers' subject matter knowledge about the human respiratory system after the workshop. Thus, a significant amount of learning among the participants was observed. Discovering teachers' misconceptions serves as an eye-opener for teacher education institutions in addressing unconfronted ideas or pre-existing ideas about the lessons they are supposed to deliver in the classroom. Process skills-based refutational teaching demonstrated its effectiveness in addressing teachers' misconceptions in a professional development program, provided that the shortcomings and oversight encountered during the workshop are addressed. Here are the following recommendations. In addressing participants who are still incorrect even after the post-test, correct answers must be discussed after the post-test to help participants see the difference between the correct understanding and the misconception. This is aligned to the inoculation stage of Taylor, which emphasizes the correct idea and labels a misconception tag on the incorrect ones to prevent students from reverting back to the misconception when encountered again in the future. More updated research on teachers' misconception must be conducted in order to serve as baseline data for professional development providers to address teachers' need for the upgrading of their science content knowledge. Further studies on the retention of teachers' correct understanding of topics after attending a professional development program should be conducted to gauge its effectiveness in overcoming the continued influencing effect of misinformation and offer better solutions for the improvement of this strategy. And finally, reasoning process of teachers participating in LAC sessions must be investigated to identify the sources of misconceptions and consequently devise professional development frameworks that could aid in reconstructing and internalizing teachers' knowledge. Thank you.